Hello everyone, welcome back to our Math A and A Analysis and Approaches Friday. We are on 1.5, okay, Arithmetic sequence. We start the concept of sequence. We'll talk about it in two chapters. We're still on topic 1, the number and algebra is still SL question. Okay, we talk about arithmetic sequence. So first of all, think about what is a sequence. Sequence is a list of number. And they have some pattern, and today's pattern is arithmetic pattern. Okay, so we have to use a formula for the m term of the arithmetic sequence. You have to find out the m term formula, and then you find out the whole sequences. So arithmetic sequence, okay, very simple. Constant differences between consecutive terms. Okay, so the second term is larger than the first term by 2, and then every term is larger than the previous one by 2. Is arithmetic sequence. Constant addition or constant reduction. Okay. And the definition of arithmetic sequence with the concept, right? The difference between consecutive terms is a constant. So if you say it means that an minus 1, okay? This term and the previous term is a constant. Okay, we call it common difference, D. And then the sequence is a1, a2 to a infinite. Okay. And then a1 is the first term. We have the name, special name for it is a. Okay. So below the first term is a, and then the common difference is d. So what is the an? Okay, it means that start from the first term, add the d to it by n minus 1 times, right? The first one doesn't need, okay? So a plus n minus 1 d. This minus 1 is the central, okay? So when you get the two terms, so ax and ay, or a4 and a2, okay? How to find the common difference? Just subtract them and also subtract the number between them, okay? And the general formula is that, oh, we start from ax, so not from a1, okay? How to find an? Easy. How many steps do you need to add? From x to n minus 6, right? So it's an equals ax plus n minus xd, okay? And then the sequence can be opposite, okay? Can have the reverse opposite of an minus 1, an minus 2, and n minus 3, okay? For example, the question tells you an minus 1 equals an plus k. Be careful, be careful. It is opposite. So the common difference is what k? It is negative k. The previous one is larger than the current one by k, okay? In other words, you can say ABCD is a sequence common difference k, okay? How about DCBA? Reverse them? Yes, they are sequence but decreasing by negative k. Be careful. So you have this thing, okay? Find the answer. Remember, bring a paper, pause, and work on it, and you will learn mathematics. It's the best way by doing example. Okay, pause. Welcome back. Remember, okay, with this system, remember, first I need to find out the common difference, right? So minus this 2 and then 6 minus 2, right? So we have it, okay? D equals minus 7 minus 5. Remember, we by the negative sign, okay? And then minus 3. Oh, common difference is minus 3. So what is the 10th term? Okay, we start from the last 6th term, okay? 7, 8, 9, 10. Okay, we have to add 4 more to it, and then it will be negative 19. Got it? Well done. And number is a sequence of diagrams. Sometimes the diagram, okay, they will draw you different diagram, and in each diagram there's number of different objects, okay, and then you look at them, and then you can find the pattern, how the number of objects changes with the number of diagram, and maybe it is a arithmetic sequence or geometric sequence, and then just find out the common difference because now we are concentrating on arithmetic sequence. Example. Okay, find out the common difference number of points between first, second, and third diagram. You got it. Well done. Yeah, first 3 times 1, 3 times 2, 3 times 3, right? So the last one is 3 times n. Okay, everyone is added by 3, and the initial term is also 3. So the equation is clean and tidy. 3n is the an. Arithmetic mean, we introduce a concept called arithmetic mean because it's come from the arithmetic sequence. For the arithmetic sequence, you know the common difference, right? So the middle term, an, is equals to the previous term and the later term. Add together and divided by 2, okay? So we call it arithmetic mean, okay? Because this is happening in the arithmetic sequence only. And so we define arithmetic mean equals a and b add together minus 2, divided by 2, okay? Actually, it's a simple average, right? Yes, and the an is also the arithmetic means of an minus 1 and an plus 1. Actually, it should be an minus k and an plus k, okay? The same separation, add together will become in the one, okay? So look at the question, okay? Don't try to find A and D. Find the 62 terms directly by the concept of arithmetic sequence. Yes, arithmetic mean, right? Yeah, the 62nd term is just these two terms arithmetic mean, right? Add them together and divide by 2. Negative 40. Easier, much easier than finding A and D, okay? Well done. Now the change of sign of terms, okay, so maybe there's a sequence before it's positive and then change to negative, or from negative to change to positive, and then they'll ask you what is the first positive term or the first negative term, okay? Remember, so find out the inequality, and then round it up the number to the first integer, okay? For example, you have the general term of the arithmetic sequence an equals a plus n minus d 1d, okay? Before it is always negative, then you want to find out the first positive term, or it's always negative before and then want to find out the first negative term, okay? So set up the equation, inequality larger than or smaller than, and then solve for n, and then round it up, and then you'll find the first positive or negative term. What I mean is like this, okay? Want the first positive term of the arithmetic sequence like this, okay? First you need to find out the an, and then set the an to be larger than 0, and then round it up, and just substitute back. Complicated. Try. Welcome back. Checking time. Yeah, first I find the common difference, okay? After minus before, okay, so 40, okay? And then the first general term is like this. The first term is negative 651, okay? Very negative. And then we set it to be larger than 0, and you find it out after some work, 17.275. So it should be 18, right? But it's not the end because it wants the term, not the number. So you need to substitute 18 back and then got it. Turn the line. Well done, you got it. And then sum of the first n terms of our missing. And then after the sequence, we want to find the sum of the sequence, okay? Sn. Sn means sum to the first n term of the arithmetic sequence. A1 plus A2 plus An, okay? We call it the sum of the first n terms of the arithmetic sequence. And if you know if it's a sequence, okay, what is An? It's the sum to the n term minus sum to the n minus 1 term, right? Very simple but very important concept, okay? For any sequence, it must be correct, okay? Okay, for an arithmetic sequence, an equals this way, right? And then what's the Sn? Remember, they pair up. The first one and the last one, the second first and the second last, okay? They pair up and add together becomes the arithmetic mean, right? So they all pair up, okay? So you can say a1 plus an is the length of the pair, okay? And how many pair are there, okay? The n term n over 2, okay? So this is the concept of addition, okay? And then you can combine them and become na plus n minus 1d over 2. This is an important equation you need to remember, okay? You really need to remember it. It's useful for the sum to the nth term for the arithmetic sequence, okay? Remember na plus n minus 1d over 2, okay? Or this concept, okay? N over 2 pair of what number? a1 plus an, okay? First and the last one, okay? And the value of a and d can be found by the summation formula. And also remember this very important point, okay? For the nth term is Sn minus 1, okay? And so you have two concepts, An and Sn, okay? So you have two equations. Possibly you can solve these two equations to find the two unknown A and D, okay? Sometimes it may lead to a quadratic equation in some calculation, okay? Let's see. Okay, you have to give a number 17 and 52. More obviously, you have set up equation for 17 and equation for 52 and then solve the A and D and just eliminate A, right? And then you can find the common difference. Okay? Try to work on it. Okay? Pause and look. Welcome back so quick, okay? So okay, sum equals this one. So sum equals A over 2 first plus last, okay? A plus like 17 and you got A equals a negative 4 and the eighth term is 17, okay? So the eighth term is 17, so 17 equals a plus n minus 1, okay? A minus 1 times d, okay? And then 17 equals 21 and d equals 3, okay? You got it? Well done. And then sometimes they want you to sum parts of an arithmetic sequence, or it's just a positive one or just a negative one, okay? They have different way to do it, okay? It's just very simple. Find a new general term for parts of the sequence. So make parts of the sequence becomes a new sequence, okay? For example, they sum the odd term, okay? A1, 3, 5, 7, blah, 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 blah. And then remember, common difference becomes 2d, right? Double. And the number of terms is because it's an odd number, so n plus 1 over 2, okay? Or sum all the even terms, okay? 2, 4, 6, 8, and then n, okay? And then common difference is still 2d, okay? But the first term is a plus d, be careful. First term change. And the number of terms is n over 2, because n is an even number. So maybe if you simply list out all the terms, odd term, even term, okay, and form the Liu sequence, and then observe how you find out the Liu common difference and the Liu first term, okay? Not that hard, okay? You can do absolute. And then find, okay, for this one, we're considering a sequence, okay? Find the sum of all the integral terms, okay? Pause and do it. Welcome back. Yes, you did it right. Bring out all the integral terms. Oh, just easy, right? So 10 terms, okay? 5 pairs, 1 plus 10, 55. Got it. And then we want to learn apply the sigma notation. Remember, you learned it in expansion, okay? And then now we want to use it as sigma notation for arithmetic sequence, okay? So summation n equals a, starting from term a to term b, right? So fa plus 1 plus 2, and then b minus 1 to b, okay? B minus, that's what c a. And then for a sequence of y equal n minus n equal 1 to n, okay, an. And then remember this summation is maybe plus or minus, so it's not equal to the absolute, okay, because they're oscillating. Example again. Welcome back, okay. How to do it? What do you need? Okay, I learned the first term, right? Number of terms first. For un equals 20, so I find out our number of terms is 8, okay? So it's sum to 8, 1, okay, so a over 2, okay? The first term I go negative 1, and then the last term is actually 20, actually is 20. So negative 1 plus 20 times a over 4, 2, 76. So application to simple interest, there's two levels of application. One is very simple, one is more complicated. Outstanding balance is the term we use in the IBDP. Outstanding balance means the total amount got, okay? It means the deposit and the interest add together, all the money you got after the end, okay? And then outstanding balance is total amount in the deposit, okay? Per annum, per year. Maybe you can per half annum or per quarter, okay? Be careful, okay? And then considering deposit and amount 8, for n periods with simple interest r, okay, so the interest is just multiply them together, right? And then outstanding balance is just adding a with it, okay. Of course, you can do a regular deposit, okay, by simple interest, okay. In n years, you deposit amount a at the start of each year, and then simple interest r%, okay, how much you got at the end of n years, so the last deposit still have interest, okay. So the last deposit, just 1 year of interest. Second, 2 years, and then last one is n years, okay. And then how to add them together, you find the constant term a, right? Then take it out first, okay. And then all the term behind it are very simple. This one, right? 1 plus 2 plus 3, okay. So it's n over 2, n plus 1, okay. Application now. How to work on it? Don't look at looks. Remember the concept, okay. Pause it and work it. Welcome back, checking time. See if you got it. Yes, you got it. 35,500. Well done. And analysis, interpretation, and prediction where a model is not perfectly arithmetic in real life. Maybe it's not arithmetic, okay? Maybe this is completely different. But they can still give you the general term an, okay? With the an even oscillating, okay? Minus 1, n plus 1, it means oscillating, and it means that the first term n equals 1, okay? It is an even number, okay? And then the a7 just substitute the number inside here, got it? And sometimes they will express it as a relationship, okay? an plus 2 equals an plus 1 minus an. Then you need to do it one by one. You got a1 and a2, and then find a3, and then find a4 and a5 and a6, okay? Very use a lot of time, but I will give you back the marks, okay? Relax. Okay, can you find the general term for this sequence? See if you get it. Lot arithmetic sequence, okay? Pause and cut. Welcome back. Can you see the pattern? First term 1, 1 plus 1, 1 plus 2. Second term 2 plus 1, 2 plus 2. N term n plus 1, n plus 2. Yeah, that's it. And remember negative 1, okay? power n because the first term is negative, so it should be power n, not power n plus 1. Okay, you got it? Well done. So thank you for going through with me. Okay, it is just elementary sharing on the arithmetic sequence. The whole syllabus you learn it. Okay, but you need time to apply it in a lot of exercise in the textbook or past paper. Okay, so work on it, start on it now. Okay, and next week come back, we will on another topic. Okay, if you like our sharing, remember subscribe and like it and share it, our channel with your friends. Okay, we hope to we can help more people. Okay, see you guys. Bye.